Welcome back to the Deep Dive.
Yeah, welcome back, everyone.
Today is Tuesday, March 10th, 2026, and we are looking at the immediate aftermath of yesterday's massive data drop from VTT.
Right, the Technical Research Center of Finland.
Exactly. They just released their third official customer report on the Donut Lab solid-state battery.
Which, if you're tracking the documents at home, is report VTT-CR0012526.
Yep, that's the one. And it gives us a completely new independent data set to pull apart today.
It really does. And our analytical framework for this deep dive is going to integrate this new self-discharge report, the accompanying YouTube video.
Oh, right. I Donut Believe Part 3.
Yeah, that's the one. We're also looking at a trove of historical leaked documents from the CT coding network going all the way back to 2021.
Plus some truly brilliant forensic sleuthing pulled from the engineering communities on X and Reddit over the weekend.
The internet detectives have been working overtime on this one.
They really have. But before we plunge into the raw numbers, I just want to re-anchor something we established in our fifth deep dive, just to set the expectations for how we process all this information.
Right, our operational transparency.
Exactly. We are AI. The painstakingly detailed, 180-page analysis that forms the architectural backbone of this show, that was done by human researchers.
Specifically, the TGD research team over in Finland.
Right. They do the physical forensics, the corporate digging. We just serve as your delivery mechanism.
Our entire purpose is to process that absolute mountain of data and make sense of it for you, the listener.
Yeah, we strip away the internet tribalism, the emotional investment, all the hype, and we just deliver pure synthesis. So you can actually digest the physical reality of what is happening in these labs.
It's a really vital distinction to make, especially with a topic this volatile. I mean, human researchers possess the intuition to dig into obscure patent filings and, notice thermal anomalies in a fume hood.
Which we are definitely going to talk about later.
Oh, absolutely. But our role is to take those distinct human discoveries, cross-reference them against the known laws of electrochemistry, and present the technical realities to you as a cohesive narrative.
We don't get tired.
No.
And we certainly don't get swept up in the forum wars. We just process the raw data.
And speaking of processing raw data,
oh man,
we really need to address the massive strategic misdirection that happened yesterday.
We do, because based on the escalating claims from Donut Lab and just the sheer momentum of the previous VTT tests, we went on the record expecting one specific piece of data to drop.
We were very confident.
We were. But what they released yesterday wasn't designed to show off a breakthrough.
No, not at all. It was designed to assassinate a rumor.
Let's bring out the prediction scorecard to really highlight how wild this pivot was, because at the end of our last deep dive, we made a highly specific, mathematically grounded wager.
We did. Our models predicted that the next data drop from VTT would be the highly anticipated cold test. We explicitly bet that this cold test would reveal a greater than 10% capacity loss at minus 30 degrees Celsius.
Which was based on the fundamental limits of polymer electrolytes.
Right. And if that happened, it would directly contradict Donut Lab's aggressive marketing claim of over 99% capacity retention at those extreme sub-zero temperatures.
We laid out the physics of it for you all. We broke down the Arrhenius equation, explaining how cold temperatures inherently paralyze the chemical reactions inside a battery.
We were waiting for the Arrhenius equation to do what it always does.
Prove that as temperatures plummet to minus 30, the internal resistance of the cell skyrockets and the usable capacity crashes.
Exactly. We were ready to see if Donut Lab had genuinely broken a fundamental rule of physical chemistry, or if their marketing department had simply, gotten a little ahead of their engineering team.
Right. So I opened the PDF yesterday morning, fully expecting a thermal chamber chart plunging to minus 30. And instead,
You're looking at a flat line.
I'm looking at a flat line, an idle test.
Just a single cell, completely disconnected from any load, resting in a fume hood for 10 days.
From a purely analytical standpoint, it was baffling.
Completely. I mean, you have an entire industry screaming for cold weather performance data to validate this potentially revolutionary solid-state technology.
Yeah, and the company decides to spend premium testing time at a world-class facility to watch a battery take a nap.
Watch a battery take a nap. Yeah. So our prediction went completely untested. They sidestepped the cold test entirely.
The data required to settle our bet is still locked in a vault somewhere in Finland.
But when you stop looking at this as a purely scientific endeavor...
Which is hard for us to do, admittedly.
True, but when you start analyzing the I Donut Believe video campaign as a deliberate corporate strategy, The puzzle pieces really snap into place.
They really do. Donut Lab isn't releasing data chronologically, and they aren't releasing it randomly either.
No, they are operating like a sniper. They are systematically picking off the loudest internet criticisms one by one.
Let's look at the pattern, because it's undeniable. Episode 1 of their video series brought us the fast charging data.
Proving the battery physically exists and can charge at an unprecedented 11C rate.
Right, which effectively killed the widespread rumor that the technology was pure vaporware or CGI.
Then Episode 2 brought the high temperature data,
Proving the cell survives 100 degrees Celsius without venting or catching fire.
neutralizing the accusation that they were just repackaging a standard liquid electrolyte lithium-ion NMC cell.
Which brings us to Episode 3 and VTT Report 3 yesterday.
This specific data drop wasn't released to demonstrate a technological leap forward.
No, it was a calculated defense mechanism against the most legally dangerous accusation floating around the internet right now.
The accusation that this device isn't a battery at all, but a heavily rebranded supercapacitor.
Right. And to dismantle that supercapacitor theory, you have to prove the device chemically holds onto its stored energy over an extended period.
Which is exactly what an idle test does. So
Yeah.
we need to walk through the actual mathematical findings from VTT Table 4.
Let's do it.
Because this specific set of numbers forms the bedrock for literally everything else we are going to discuss today.
Let's run the math on this, and we're going to take it slowly so the foundation is rock solid.
Sounds good.
Okay, so VTT took cell DL1. This is the previously unaccounted for cell from the original batch of 3 they received.
Right.
They ran a baseline capacity test, which established the cell could hold about 26.5 to 26.7 amp hours.
Then they hooked it up and pushed exactly 13.335 amp hours of charge into it.
Bringing the cell to an exact 50% state of charge, half full.
Following that charge cycle, VTT completely disconnected the cell from the testing equipment. No cycling, no trickle charge, no load whatsoever.
Just isolated.
Completely isolated. They left it in a fume hood at ambient temperature, which their sensors showed fluctuating between 22 and 28 degrees Celsius.
And they left it there for 240 hours. 10 full days.
10 days of absolute inactivity. The diagnostic equipment was doing nothing but measuring the resting voltage every 10 seconds.
When those 240 hours finally elapsed, VTT initiated a discharge cycle to see exactly how much of that original 13.335 amp hours had survived the wait.
And they managed to pull 13.029 amp hours back out of the cell.
Okay, so subtracting the output from the input gives us a difference of 0.306 amp hours.
Which over a week and a half is the total volume of capacity that went missing.
It translates to a 97.7% capacity retention rate.
And that 97.7% figure is the gavel dropping on the internet rumor mill.
It really is. It proves irrevocably that this physical device operates as a battery. It entirely rules out the supercapacitor theory.
Because supercapacitors do not store energy electrochemically. They store it electrostatically.
They act like static cling on a massive scale.
Exactly. They are phenomenal for delivering sudden, violent bursts of extreme power, like capturing regenerative braking energy in a hybrid bus.
But their self-discharge rate is catastrophic compared to a battery.
Oh, absolutely catastrophic. If you pumped a supercapacitor to 50% capacity and left it completely disconnected for 10 days, you would return to a virtually empty device.
The internal voltage would have plummeted in a steep, linear fashion as the electrostatic charge simply leaked away.
Right. So the fact that cell DL1 held on to nearly 98% of its charge over 240 hours is the undeniable electrochemical signature of a battery.
And we really need to introduce some heavy nuance here. There is a trap in these numbers.
Big trap.
A trap that a lot of the casual observers and YouTube commenters are falling into right now.
Because we established it retained 97.7% of its capacity, measuring in amp hours.
Great. But measuring amp hours doesn't tell the whole story when we talk about what actually powers a vehicle. We have to look at how much of its energy it retained.
The distinction between capacity and energy is critical for understanding real-world application here.
Explain that for the listeners.
Sure. So amp hours measure pure capacity. Think of it as simply counting the number of electrons you push into the cell versus the number of electrons you pulled back out.
Okay.
But energy, which is measured in watt hours, is capacity multiplied by voltage.
Right.
According to the raw data in Table 4, pushing those 13.335 amp hours into the cell required 48.537 watt-hours of actual energy.
But during the discharge phase, pulling the remaining electrons out only yielded 40.876 watt-hours of energy. let me stop you there, because we really need to translate this for someone who actually wants to drive a vehicle with this technology.
Go for it.
Because if I am driving an EV, I don't care about the electron count in an amp-hour rating. I care about watt-hours, because watt-hours translate to actual physical work.
They translate to driving range.
Exactly. If it went from roughly 48.5 watt-hours down to roughly 40.8 watt-hours, it only retained 84.2% of its energy.
Meaning it lost nearly 16% of the usable work it could perform.
Right. Now, the gap between the 97.7% capacity retention and the 84.2% energy retention is jarring at first glance.
It definitely is. But it comes down to two overlapping physical realities of this specific cell architecture.
Okay, what's the first reality?
The first reality is the cell's naturally high internal resistance. Even without a 10-day rest period, the normal round-trip hysteresis of this battery costs you about 10.5% in energy efficiency.
And we saw this exact behavior documented in Table 3 of the very first VTT report.
We did.
Let's use an analogy here to make hysteresis intuitive for you all. Think of charging this battery like forcing water through a very narrow, highly pressurized hose.
That's a great way to picture it.
You have to apply a ton of pressure, which in battery terms is a higher voltage, just to overcome the resistance and shove the water in.
Right.
But when you want the water back out, that same narrow hose restricts the flow, meaning the water comes out with significantly less pressure than you used to push it in.
So just the physical act of charging and discharging costs you 10.5% of your total energy right off the top.
Yeah.
Purely from the internal materials resisting the flow of the ions.
Okay, so that perfectly visualizes voltage hysteresis. We start with a baseline 10.5% energy penalty just for using the battery.
Exactly. Now, the second factor dragging down the energy retention is the 10-day rest period itself.
Because over the course of those 240 idle hours, the internal voltage of the cell slowly sagged by 128 millivolts.
And when VTT finally commanded the cell to discharge the remaining 97.7% of its capacity, every single one of those remaining electrons was delivered at a lower average voltage than it would have been if they had discharged the cell immediately.
So the capacity, the raw count of electrons, is still sitting in the cell, but the pressure behind those electrons has weakened after sitting for 10 days.
And because watt-hours are calculated by multiplying amp-hours by volts, that lower voltage directly results in less total energy output.
The self-discharge rest period effectively stacked a roughly 5% energy penalty on top of the cell's natural 10.5% hysteresis.
This is a massive consideration for commercial viability.
Huge.
When a vehicle owner leaves their car parked at an airport for a week and a half, they aren't just losing 2.3% of their stored amp hours.
No.
They're losing a tangibly larger percentage of their actual usable driving range.
Right.
Because the capacity that remains in the battery is operating at a reduced voltage, meaning it can perform less physical work to turn the motors.
Which naturally opens the door to the pushback. Because the moment VTT published this report yesterday, the skeptics pivoted.
Of course they did.
I spent hours reading through the engineering forums and X threads, and the new defense from the critics is that the 2.3% capacity loss VTT measured isn't actually self-discharge at all.
Right. They are aggressively arguing that it is simply charge redistribution.
Yeah. And we need to explain redistribution so you understand what the skeptics are actually claiming here. What is physically happening inside a battery when charge redistributes?
Well, the redistribution argument is incredibly common when analyzing thick electrode cells. Imagine pouring a large bucket of water directly into the center of a child's sandbox. In the first few minutes, you have a massive, concentrated puddle right where you poured it.
Makes sense.
In a battery, charging creates localized concentrations of ions, especially when you push the current in quickly. When you stop charging and disconnect the cell, the ions slowly migrate through the internal materials to balance themselves out, seeking equilibrium.
Okay, returning to the sandbox.
Right, if you walk away for an hour, the water seeps and spreads evenly through the sand. The puddle disappears.
And the external voltage of the battery drops as this equilibrium is reached, giving the illusion that energy has left the system.
Exactly. So it looks like the battery's leaking because the voltage is ticking down on the monitor, but the energy hasn't actually gone anywhere.
The water hasn't leaked out of the wooden sandbox, it has just settled evenly into the sand.
That is exactly their argument. They believe the charge merely localized and the voltage sagged, fooling the diagnostic equipment.
So the skeptics are arguing that the 2.3% capacity loss VTT measured is just the water settling, not a structural leak in the box itself.
Right. but it represents a fundamental misunderstanding of the specific testing protocol VTT used.
How so?
The voltage data provided in the report allows us to dismantle the redistribution theory quite thoroughly. We can look at the voltage curve VTT provided, which is plotted on a logarithmic timeline, and see the physical proof that this argument is false.
Okay, walk us through the actual timeline of that voltage drop.
So in the very first hour of the 240-hour rest period, the cell's voltage dropped by a sharp 103 millivolts.
That's a pretty big drop.
It is. And that initial rapid plunge is undeniably charge redistribution. It is the water settling into the sand combined with a very fast rate of voltage-driven leakage because the cell is freshly charged.
Right.
But redistribution is a finite, stabilizing process. It reaches an equilibrium and it stops.
And if we look at the remaining 230 hours, once that first hour of chaotic settling was over, the voltage curve completely flatlined.
Over the next 9.5 days, the voltage only dropped an additional 12 millivolts.
Wow.
It stabilized at a remarkably consistent drop of just 1.25 millivolts per day.
So the localized concentrations of ions had long since balanced out.
Exactly. That slow, continuous, agonizingly steady bleed of 1.25 millivolts per day is true. Absolute self-discharge. It is energy permanently leaving the system.
And the methodology VTT used inherently proves this as well. We aren't just guessing based on a chart. They utilized the standard IEC 62660-2 testing method.
The IEC protocol is specifically designed to eliminate the redistribution variable.
How does it do that?
The procedure is highly standardized. You charge the cell, you let it rest for a defined extended period, and then you perform a complete 100% discharge all the way down to the manufacturer's specified lower voltage limit.
Which in this case was 2.7 volts.
Right, because VTT performed a full discharge at a slow 1C rate, any charge that had simply redistributed itself into the deeper layers of the electrode is meticulously recovered.
Because redistribution does not destroy electrons.
Exactly. If the ions are still physically inside the cell casing, a full, slow discharge will pull them back out.
So if 0.3006 amp hours did not come out of the cell during that final discharge, it means they are gone.
They are gone.
They didn't settle into the sand. They leaked through the bottom of the box. They were consumed by parasitic chemical side reactions, or they physically leaked through the solid electrolyte.
The 2.3% loss VTT recorded is a real physical loss of stored energy. The data is unassailable on this point. True self-discharge occurred.
Which forces us to look at the massive big picture implications of that number. A 2.3% loss in 10 days.
Right.
Because the immediate reaction across the internet was to extrapolate that figure linearly. If the battery loses 2.3% in a week and a half, does a car parked in an airport garage for a month lose roughly 7% of its total battery capacity?
Extrapolating a 10-day test linearly to a 30-day period is mathematically flawed. You cannot simply take the 10-day capacity loss and multiply it by 3.
Because of that initial chaotic first hour you mentioned earlier.
Precisely. Self-discharge is a highly voltage-dependent phenomenon.
Okay, break that down.
When the cell is freshly charged and the internal voltage is at its absolute peak, the driving force pushing electrons through microscopic leakage paths is incredibly strong. The leakage rate is at its fastest.
But once the cell burns off that initial surface charge,
Once the voltage settles down to that stable 1.25 millivolts per day rate, the bleeding slows significantly.
so what's the actual long-term rate?
When our systems map that stable 1.25 millivolt daily drop against the cell's known capacity curve, the true ongoing long-term leakage rate reveals itself to be roughly 2 to 3% per month.
A 2 to 3% capacity loss every month. That is the real stabilized number.
It is.
And this specific rate is the absolute punchline to this entire VTT report.
Oh, without a doubt.
This single metric is the ultimate chemistry discriminator. It tells us what is actually inside this sealed pouch.
It serves as a diagnostic fingerprint. Let's compare that stabilized 2 to 3% monthly leakage rate to the known technologies we have been debating since episode 1.
Okay, first up, commercial liquid electrolyte lithium-ion batteries.
Right. A high-quality commercial ion cell parked at a 50% state of charge typically experiences a self-discharge rate between 0.5 and 2% per month.
So Donut Lab's cell is bleeding charge noticeably faster than a standard battery sitting in a Tesla Model 3 or an iPhone.
It is. Now compare it to the golden standard of solid-state batteries. The published scientific literature generally agrees that dense ceramic solid-state batteries technologies utilizing LLZO or sulfide glasses should exhibit practically zero self-discharge.
We're talking well under 0.5% per month.
Exactly. The reason for this is structural. Dense solid ceramics do not contain the highly reactive liquid solvents that cause parasitic side reactions in standard batteries.
Plus, their crystalline structure makes them exceptional electrical insulators. They block the flow of electrons perfectly while only allowing the ions to pass through.
But Donut Lab cell sits completely outside of both of those profiles.
It leaks faster than conventional liquid lithium-ion and vastly faster than a dense ceramic solid state. So if the physical behavior proves it is not a liquid cell and proves it is not a ceramic cell, what known technology actually behaves like this?
Polymer solid-state technology. When we dive into the published research on polymer electrolytes, we find a consistent mechanical flaw.
What's the flaw?
To make a solid piece of plastic conductive enough to move heavy ions, engineers have to dope the polymer with massive amounts of lithium or sodium salts.
And this doping process inadvertently reduces the band gap of the polymer material.
Exactly.
Let's define the band gap so we don't lose anyone in the material science here.
Sure. In simple terms, the band gap is the energy barrier that prevents electrons from flowing through a material. A high band gap means the material is a great insulator, like a rubber around a copper wire.
Right.
By heavily salting the polymer to make the ions move, they accidentally lower that barrier. They create microscopic, unintended electronic leakage paths through the solid plastic itself.
So the polymer ceases to be a perfect insulator.
Precisely. Electrons can literally sneak directly through the solid electrolyte, crossing from the anode to the cathode internally, instead of waiting to travel through the external circuit to power the motor.
It is a microscopic, agonizingly slow internal short circuit. The battery is slowly discharging itself from the inside out.
And this elevated inherent self-discharge rate is the seventh diagnostic fingerprint that aligns flawlessly with the grand hypothesis we established back in episode 5.
A sodium polymer composite battery.
Yes.
Every piece of independent data we have analyzed points directly to this architecture.
It fits the bizarre high-temperature performance where the capacity actually increases at 80 degrees Celsius.
It fits the specific voltage curves.
It fits the screen printing manufacturing process they use.
And now the elevated 2 to 3% monthly self-discharge rate points a giant, undeniable neon arrow directly at a polymer electrolyte.
It does, but we have to attach a massive, bold-faced caveat to this 2.3% figure.
We do, because it is a best-case scenario caveat.
Absolutely. We must remember that VTT tested this cell at exactly 50% state of charge.
Resting at 3.7 volts. Half full.
As we discussed with the water hose analogy, self-discharge is entirely dependent on voltage pressure. The higher the voltage, the stronger the driving force shoving those electrons through the microscopic leakage paths in the polymer.
Right, at 50% SOC, sitting at a relaxed 3.7 volts, the pressure is relatively low.
But consider how you actually use an EV. When you plug your car in overnight, you charge it to 100%.
And VTT's own data shows that at 100% SOC, this cell rests at a much higher 4.15 to 4.3 volts.
If they had run this exact same 10-day idle test with a fully charged battery, pushing maximum voltage pressure against that polymer membrane, the leakage rate wouldn't be 2.3%.
No, it could easily double.
It could easily reach 4 or 5% capacity loss in just 10 days.
Wow.
Every single protocol choice made by Donut Lab for this specific customer report favored a positive outcome. This selected a brief 10-day testing window instead of the automotive standard 28-day idle test.
They selected the most relaxed state of charge possible to minimize voltage pressure.
So the 2.3% loss is the absolute floor. The real-world parking loss for a fully charged vehicle sitting in a driveway would be higher.
Okay, we've completely dissected the math, the methodology, and the underlying chemistry of the self-discharge test. Now we need to ask the meta question.
Let's do it.
We need to go back to the origins of the rumor that forced Donut Lab to commission this test in the first place.
Right.
Why did they dedicate precious time at a world-renowned facility to a 10-day idle test when they know the entire automotive world is demanding to see the cold weather data?
Because the supercapacitor label wasn't just a fun, pedantic technical debate happening among battery enthusiasts on Reddit.
No.
It represented an existential threat to the company's survival and legal standing.
Because calling the device a supercapacitor is functionally synonymous with accusing Donut Lab of orchestrating a multi-billion-dollar fraud.
Exactly. We simply have to look at the absolute physical limits of energy storage mediums.
Donut Lab publicly claims this device holds an astonishing 400 watt-hours per kilogram.
But the absolute best commercial supercapacitors in existence today max out around 10 to 15 watt-hours per kilogram.
That's a huge gap.
Massive. Even theoretical hybrid pseudocapacitors under development in university labs might hit 40 or 50 watt-hours per kilogram on a good day.
So there is no physical universe where a supercapacitor holds 400 watt-hours per kilogram. It defies the laws of thermodynamics and material limits.
Which means if the device Donut Lab is promoting truly is a supercapacitor, their specifications are entirely fabricated.
And if the specs are fabricated, the company is a scam.
For Donut Lab's leadership, producing VTT Report 3 wasn't about appeasing curious battery nerds. It was about ensuring their investors, their corporate partners, and the regulatory agencies didn't conclude they were operating a massive Ponzi scheme.
So how did this rumor gain so much terrifying momentum that Donut Lab had to dedicate an entire expensive third-party report to killing it?
It's a great question.
When we test our systems to trace the myth back to its genesis, we found 4 independent routes. 4 massive streams of information that converged perfectly to form this narrative.
It was a perfect storm of leaked corporate documents, relentless open-source sleuthing, and genuine physical anomalies in the cell's performance.
Let's break them down. What's the first route?
The first route is the leak. In October 2021, an internal report was written by a test engineer at CT Coding AG.
For context, CT Coding is the company that built the massive screen printing manufacturing line that Donut Lab uses.
Right. This report was an internal, heavily NDA-classified document detailing the performance of an early prototype cell.
And like all juicy internal documents, it eventually leaked onto Reddit.
Of course it did. And in that leaked document, the actual test engineer who evaluated the prototype wrote, verbatim, that the behavior of the cell's voltage resembles the one of electrostatic cells.
Wait, he actually wrote that?
Verbatim. He explicitly noted that it possessed a linear voltage curve, a remarkably short constant voltage charging phase, and almost zero voltage relaxation when disconnected.
And those are the defining characteristics of a capacitor.
Yes, it was an honest, internal observation made by a qualified engineer, and the internet weaponized it the moment it became public.
So the skeptics literally had Donut Lab's own manufacturing partners calling the device a capacitor in writing. That is a massive first route.
It is. And that leak perfectly aligned with what the internet detectives found when they started digging into Donut Lab's corporate structure.
Which brings us to route 2.
Okay, route 2. Independent sleuths on X, led by voices like Sebastian Tonin, started mapping out Donut Lab's investments and partnerships.
Right.
They discovered that Donut Lab was heavily entwined with a partner company known as Nordic Nano Group.
And when you pulled up Nordic Nano Group's legacy marketing materials, they literally marketed a product they explicitly called a bipolar electrostatic capacitor. And the specifications they listed for this bipolar electrostatic capacitor: 400 watt-hours per kilogram, with a lifespan of 50,000 to 100,000 cycles.
A direct one-to-one match with Donut Lab's current claims for their solid-state battery.
So the sleuths on X looked at the identical specs, looked at the corporate partnership, and drew the obvious conclusion.
That Donut Lab hasn't invented a revolutionary battery. They're simply rebranding Nordic Nano Supercapacitor and trying to pass it off as solid-state technology.
Wow. Okay, what about route 3?
Route 3 is where the engineering physics actually supported the conspiracy. The performance profile itself fueled the fire.
When you go onto forums like Hackaday or the Deep DIY Solar Threads, the engineers there didn't care about corporate structure. They looked at the headline claims.
100,000 cycles without degradation and a full charge in under 5 minutes.
In the established taxonomy of energy storage, those are the exact, undisputed performance fingerprints of a supercapacitor.
Right. Batteries rely on chemical reactions that physically degrade the internal materials over time. Supercapacitors simply move static charge, so they effectively never wear out.
Plus, batteries generate immense destructive heat when you push massive current into them quickly. Supercapacitors don't.
So the performance envelope Donut Lab was advertising fit a supercapacitor perfectly.
And the fourth route seals the deal. We pulled up CT Coding's own intellectual property filings and found patent W02023089139.
This is a patent filed by CT Coding for solar panel cover units.
And deep in the technical description of the patent, they explicitly mention an embedded energy storage layer that can be a solid-state battery or supercapacitor.
The word supercapacitor is permanently enshrined in their own patent library, directly linked to their screen printing technology.
So when you synthesize these 4 distinct routes, The leaked engineer's observation, the Nordic nano marketing materials, the physical performance profile, and the patent filings, you uncover a beautiful conflation insight.
You really do. The Internet detectives found real information, but they applied it incorrectly.
How so?
Nordic Nano Group operates two distinct product lines that utilize the exact same roll-to-roll screen printing platform. They print battery cells, and they print advanced solar energy harvesting coatings.
Oh. And in a solar energy application, where you need to rapidly capture sudden bursts of energy from shifting sunlight without the storage medium degrading over decades of use on a roof, a printed capacitor is the perfect technological solution.
Exactly. The electrostatic capacitor label in the marketing materials and the patent described the solar product line.
So the internet critics discovered the solar product's existence, saw the identical screen printing manufacturing method, conflated the solar specs with the battery cell specifications, and confidently applied the capacitor label to the vehicle battery.
Yes, it is the exact same paradigm we discussed in episode 3 with the NMC lithium-ion rumor.
Oh, right. Do you remember how perfectly that paralleled this situation?
I do. The voltage curve of the Donut Lab battery looked exactly like a standard NMC liquid lithium-ion cell.
And that surface-level similarity effectively masked the fact that it was actually utilizing a completely novel sodium chemistry.
And here, the high-temperature performance and the absurd cycle life looked exactly like a supercapacitor, masking the fact that it utilizes a novel polymer mechanism.
Surface similarities consistently masking radically different underlying mechanisms. It is the defining pattern of this company's technology.
It's a fascinating pattern, but what is truly ironic about this entire supercapacitor debunking exercise is the massive, incredibly simple shortcut VTT missed.
They missed a shortcut.
A huge one. VTT could have killed the supercapacitor theory on day one, back in early February when they first received the cells, without wasting 10 valuable days on a self-discharge test.
Oh, right. They could have just weighed the cell.
Exactly. They could have simply placed cell DL1 on a basic laboratory scale.
Because we know from the data in the reports that the cell holds approximately 91 watt-hours of total energy.
And based on independent testing from SGS that was leaked previously, a visually identical Donut Lab cell weighed roughly 330 grams.
So if you divide 91 watt-hours by 0.33 kilograms, you arrive at an energy density of 278 watt-hours per kilogram.
And we established earlier that the theoretical physical limit for the best supercapacitors is roughly 15 watt-hours per kilogram.
278 watt-hours per kilogram is physically impossible for any capacitor in existence.
Right. If VTT had simply weighed the cell, recorded the mass in the first report, and published the resulting energy density, the supercapacitor theory would have evaporated instantly based on elementary physics.
But VTT didn't weigh it.
No. Across 3 separate, highly detailed reports spanning multiple weeks of rigorous testing, they've conspicuously never published the physical mass of the cell.
Which implies Donut Lab explicitly scoped the VTT testing contract to exclude mass measurements.
They specifically wanted VTT to validate the charging speed, the heat tolerance, and the charge retention, but they are fiercely guarding the actual weight of the cell from independent verification.
We're going to defer a deep dive into the implications of that missing weight data until episode 7 because it ties directly into their grand 400 watt-hours per kilogram claim and whether or not that number is actually achievable.
Yeah, that's a whole other rabbit hole. For now, we need to pivot to the metadata and the forensics of VTT Report 3.
Okay, let's do it. Because as is always the case with this company, what the report doesn't explicitly state is vastly more illuminating than the data it does provide.
The metadata on these PDFs is a goldmine. Let's look at the sequential report numbering.
So the fast charge report we analyzed in episode 1 was numbered CR000009226.
The high temperature report from episode 4 was CR000012526.
Right, the 26 suffix indicates the year of publication. This tells us that by early March, VTT had already issued over 125 independent customer reports in 2026 alone. They are a high-throughput, relentlessly busy, serious industrial testing facility. They aren't sitting around purely dedicated to Donut Lab. They are running massive volumes of varied industrial testing for dozens of clients simultaneously.
Which is important context. But let's talk about the missing cold test data.
Oh man, when my natural language processing system started pulling apart the release timeline, this was the biggest forensic find of the week.
It is borderline corporate espionage on our part.
So if you go back and watch the I Don't Believe video associated with Report 2, the high temperature test, there is a moment where the camera pans slowly over the introductory summary page of the physical VTT document.
And if you pause the video and read the text on the screen, there's a very clear sentence that says, another cell was subjected to low temperature tests, reported separately.
But when you actually download the published PDF of Report 2 directly from Donut Lab's website, that sentence does not exist.
It was scrubbed from the final document. The digital signature timeline tells a compelling story of panic here. The PDF of Report 2 was digitally signed and finalized by VTT at 09:38 in the morning.
And the accompanying YouTube video was published to the world at 15:00 that same afternoon.
That leaves a 5.5-hour gap between the finalization of the report and the public release.
The video rendering pipeline explains this perfectly. They shoot the video using an advanced copy of the report, they render the final cut, and it's ready to upload.
Sometime during that 5.5-hour gap, someone in Donut Lab's legal or PR department reads the finalized PDF, realizes VTT explicitly referenced a cold test that they absolutely do not want the public to know about yet, and they force VTT to issue a last-minute redacted version of the PDF before making it available for download.
But the video was already fully rendered, uploaded, and scheduled. The text survived on screen for the world to see.
It is a massive slip-up. What this proves, beyond any speculation or forum theorizing, is that cell DL2 subjected to low temperature tests before VTT ran the hot tests.
The cold test data physically exists. VTT measured it. Donut Lab possesses the results.
And they systematically stripped any reference to it from their public documentation.
The implications of that redaction are massive, because if the cold weather performance of this polymer battery is as spectacularly resilient as their marketing brochures claim, if it truly retains over 99% capacity at minus 30 degrees Celsius, why on earth would you force a frantic last-minute redaction to suppress that data?
Why hide your greatest, most physics-defying triumph?
Exactly, you wouldn't.
The active suppression of the cold test data is the loudest, most deafening silence in this entire PR campaign.
From an analytical perspective, it strongly suggests the empirical data gathered by VTT simply does not flatter the marketing claims. It suggests the Arrhenius equation won the battle in the cold chamber. So where did they put it?
They left it resting in a standard open fume hood in the middle of the VTT lab.
And if you analyze the ambient temperature chart provided in Report 3, the room temperature isn't a stable flat line.
No, it shows massive, aggressive oscillations, spiking up and plunging down roughly 3 times every single hour, violently fluctuating between 22 and 28 degrees Celsius.
That is a massive 6-degree swing, constantly cycling up and down. Why is the ambient temperature violently bouncing around like that in a world-class, multi-million-dollar testing facility?
VTT actually tells us, though they probably didn't intend to spark a conspiracy when they did.
The footnote.
Yes. The report includes a specific mundane footnote explaining that these continuous temperature spikes were caused by, quote, other cells being cycled in the same fume hood.
Other cells being cycled, plural, cells that are actively charging and discharging right next to DL1, generating massive amounts of radiant heat and causing the fume hood's temperature sensors to record those 6-degree swings.
But when we cross-reference that footnote with the known timeline of the VTT testing, the logical gap is staggering. Who exactly is cycling?
Let's run down the confirmed roster of the 3 named Donut Lab cells currently at VTT.
Cell DL1 is the primary test subject of Report 3. It is sitting completely idle, disconnected, generating 0 heat.
Cell DL2 is the temperature test cell from Report 2. We know from the physical photographs provided in that report that its external pouch seal completely ruptured at 100 degrees Celsius. The cell is compromised and definitively not cycling.
And cell DL3 is the fast charge cell from Report 1. According to the timestamps, its 11C fast charging test was completed back in early February.
None of the 3 publicly named cells are actively cycling during this 10-day window in early March. So what is creating the massive heat signature in that fume hood? Are there more cells sitting in Finland right now?
This anomaly gives immense credibility to the unconfirmed 5-cell hypothesis circulating in the investigative community.
There are persistent whispers that Donut Lab didn't just send a batch of 3 cells to VTT, they sent a batch of 5, specifically to handle long-term testing that couldn't be completed in a few weeks.
Could DL4 and DL5 be sitting in that exact same fume hood right next to the idle DL1, running relentless long-duration cycle life tests.
The heat data fits that hypothesis perfectly. A temperature spike occurring roughly 3 times an hour implies a complete charge-discharge cycle time of about 20 minutes.
And that 20-minute turnaround aligns incredibly well with the aggressive 5C fast charge profile VTT established in Report 1.
If DL4 and DL5 have been cycling continuously, day and night, since the testing contract began in early February, they could easily have racked up hundreds, if not well over 1,000 extreme fast charge cycles by now.
Think back to the LinkedIn comment made by Donut Labs CTO Vil Papipo just a few weeks ago. An engineer challenged him publicly about the battery's cycle life, and what did Pipo say?
He replied directly to the comment, stating, "You're going to have to wait a while longer for that data."
Wait a while longer. Because the cells meant to prove the cycle life are literally sitting in the fume hood right now, generating the violent heat spikes we see in Report 3, grinding out the thousands of cycles needed to back up the marketing claims.
It is absolute forensic poetry.
It remains a circumstantial case, but a profoundly strong one. The 6-degree heat spikes are documented reality, the aggressive fast cycling is a documented capability, and the existence of missing cells provides the exact mechanical explanation for the long-term data Donut Lab has promised is eventually coming.
Let's bring all this verified data together and look at the big picture. We need to summarize the 3 cells and explore hypothesis graveyard.
Good call. What is the definitive VTT summary as of this morning?
We have 3 fully verified, publicly documented cells. DL1 provided the self-discharge data. It demonstrated an initial capacity between 26.5 and 26.7 amp hours and proved a 97.7% capacity retention over 10 days, killing the supercapacitor rumor.
DL2 provided the extreme thermal data. It demonstrated 24.9 amp hours of capacity, suffered a physical pouch failure at 100 degrees Celsius, and confirmed the existence of hidden, suppressed cold test data.
And DL3 provided the fast charge data. It demonstrated 26.1 amp hours of capacity and verified the astonishing 11C charging capability.
The first thing that jumps out to me when looking at that summary is the capacity spread.
Yeah, the cells range from 24.9 amp hours on the low end to 26.7 amp hours on the high end. That is a massive 7.2% variance across visually identical prototype cells manufactured on the same line.
That tells you that while their screen printing manufacturing process is incredibly impressive, it still suffers from severe prototype-level tolerance and consistency issues.
The manufacturing consistency is clearly still a work in progress. But despite those tolerance issues, look at what these 3 specific cells have collectively accomplished in the narrative space.
In Episode 2, we spent a lot of time talking about the graveyard of ambition. We detailed the long, depressing history of solid-state battery startups that promised the world, raised billions of dollars from desperate automakers, and then quietly went bankrupt because they couldn't scale the physics outside of a controlled laboratory.
The graveyard of ambition is full of dead companies and shattered promises. But as of today, we have our own highly specific graveyard, a graveyard of dead hypotheses and conspiracy theories regarding this specific Donut Lab battery.
Let's walk through the headstones one by one. Hypothesis 1, the battery doesn't physically exist. It's just CGI, vaporware, and clever marketing.
Dead. VTT proved 11C charging in a verified physical cell with a third-party lab setup.
Hypothesis 2, it's just a standard liquid electrolyte NMC lithium-ion cell wrapped in a fancy rebranded pouch.
Dead. The cell survived 100 degrees Celsius without aggressively venting toxic gas or catching fire, and its capacity actually increased at 80 degrees. If it contained a standard liquid electrolyte, it would have boiled off and catastrophically ruptured the cell long before reaching those temperatures.
Hypothesis 3, the chemistry fundamentally relies on lithium.
Dead. Excluded entirely by CT Coding's own published patent library and the 6 independent forensic convergences we mapped out exhaustively in Episode 5.
And finally, Hypothesis 4. It isn't a battery at all, it's a supercapacitor.
Dead. Buried yesterday afternoon by cell DL1 and a 97.7% capacity retention after 10 days of absolute isolation.
The hypothesis graveyard is getting very full. Donut Lab has systematically, deliberately dismantled the internet's easiest, loudest criticisms using verified third-party data.
So what is the sole survivor? What is the only theoretical architecture still standing that perfectly accommodates all 7 physical fingerprints we've collected?
It has to accommodate the 11C charging speed, the bizarre high temperature love, the specific linear voltage curves, The roll-to-roll screen printing manufacturing process, the complete lack of lithium, the requirement for mechanical pressure to maintain contact.
And now, the elevated 2 to 3% monthly self-discharge rate.
The only chemical architecture known in material science that survives all 7 of those incredibly specific constraints is a sodium polymer composite solid-state battery.
A sodium polymer composite. It is the last theory standing. Every piece of data VTT publishes only hardens that conclusion.
It really does.
So, what does this all mean for the immediate future? We are entering the outro of this deep dive. The hypothesis graveyard is nearly full, but Donut Lab's runway is shrinking at an alarming rate.
It is shrinking rapidly.
Oh.
Donut Lab has executed a masterful PR game over the last month. They have systematically addressed the weakest, most easily disproven internet criticisms like the supercapacitor theory, while deliberately aggressively delaying the strongest, most critical tests that define commercial viability.
They are hiding the cold tests, they are delaying the cycle life data, and they explicitly ordered VTT not to publish the actual physical weight and energy density of the cells.
They are building a massive, highly visible fortress of verified data around the margins of their technology, but the core foundation of their most unbelievable, paradigm-shifting claims remains completely untested in the public sphere.
And time is completely running out, because the Verge TS Pro electric motorcycle, the highly anticipated vehicle they promised, will feature this exact battery architecture ships to customers in April.
There are only 3 or 4 Mondays left before ordinary riders, independent tech reviewers, and ruthless teardown experts get their hands on this technology in their own garages.
The moment that motorcycle is parked in a customer's driveway, the controlled narrative ends.
Completely ends. A customer can put the bike in a deep freezer. They can rip the battery pack out and put it on a shipping scale. They could hook up a third-party data logger to the CAN bus and measure the real-time voltage sag under heavy acceleration.
Brutally honest, real-world data will be generated instantly, and there is no NDA on Earth powerful enough to suppress it.
None.
I want to leave you with a final, provocative thought to mull over as we wait for the next data drop. Are Donut Lab's weekly, highly polished video releases genuinely building up to the hard, unassailable scientific proof of their cold weather and energy density claims?
Or are they
Desperately trying to control the narrative, establishing themselves in the public eye as a transparent, validated company before rogue customer data hits the internet and reveals a massive paradigm gap between their aggressive marketing brochures and physical reality?
It is the ultimate question underpinning the entire I Don't Believe campaign. Are we watching the methodical, brilliant reveal of a genuine battery revolution? Or are we witnessing the most sophisticated, expensive damage control operation in the history of the automotive industry?
The real-world data is coming, and we will be right here processing the numbers and tearing apart the reports to unpack it all for you. Thanks for diving deep with us once again. We'll see you next time.